In this video, we're going to talk about inverse functions. And we just learned about one-to-one functions. Well, the reason we study one-to-one functions is that one-to-one functions all have inverse functions. Okay? The notation we use, so f is our notation to represent our function, then f inverse would represent its inverse. Okay? F is my one-to-one function. F inverse is its inverse. Okay, so that's the notation. Now, what is the inverse? And why is it interesting to us? Well, we think of it as an undoing function. The inverse undoes, this is kind of a way to think of it, what f has done. So what do I mean by that? Well, if f takes the value 3 or the input 3 to the output 4, then the inverse function would take the value 4, which would be its input, and its output would be 3. Okay? So if f maps 3 to 4, f inverse will map 4 to 3. So, let's kind of look at a little chart to visualize it in another way. So if this represents the domain of f, and x is in the domain of f, and it gets mapped over here to a y, and recall this is a one-to-one function, which means there's only, for this y right here, this is the only x that had its mapping to it. So f will take x to this y. F inverse will take that y right back to that very same x. Okay? Now let's look at an example of it when we write f as a set of ordered pairs. So, if, let's move this up a little bit. If f is equal to this set, 1, 2, 3, 4, 6, 10. We see that it's a function because each first coordinate has exactly one second coordinate, and we see that it's a one-to-one function because each second coordinate has exactly one first coordinate. Since it is a one-to-one function, we know that it has an inverse. Well, all the output values become the input values for f inverse. So 2 gets mapped to 1, 4 gets mapped to 3, and 10 gets mapped to 6. Now, you should notice something else that you can say. The domain of f is equal to all the first coordinates, so it consists of 1, 3, and 6. The range of f is all the second coordinates, 2, 4, and 10. And look at what we can say about the domain and range of f inverse. The domain of f inverse is equal to 2, 4, 10, and the range of f inverse equals 1, 3, and 6. That's very interesting. So we could reword that and say that the domain and range of f are the range and domain of f inverse. They flip-flop. So the next question we might ask is, what would the inverse function look like graphically if we compared it to the original function? Well, let's look at a particular graph and see. So this blue graph right here will represent the graph of f, and notice that it is a function. It passes the vertical line test, and that it is also a one-to-one function. It will pass the horizontal line test. Since this function f is one-to-one, we know that it has an inverse. Let me identify or label this. So this is the graph of f. Well, like we were discussing on a previous slide, that the domain and range of our function f flip-flop with the range. Okay? So let's see what these 3 points, we're going to see what happens to them, live on the graph of f. And so what does that mean? Well, that means, let's use this correct color, f of 0 equals 1, f of 2 equals 3, and f of 3 equals 5. So f takes 0 to 1, 2 to 3, and 3 to 5. Well, the inverse is going to take 1 to 0, 3 to 2, and 5 back to 3. So let's plot those points. So instead of the point 0, 1, we would plot the point 1, 0. Instead of the point 2, 3, we're going to plot the point 3, 2. And instead of the point 3, 5, we're going to plot the point 5, 3, which is going to lie right there in the middle of that. Now, if we connected our graph, it would look like that. And we would be correct. Now here's something I want you to notice. If I were to construct the line, and I'm going to do it in a dotted line, y equals x, it's going to pass through all these corners, and it goes that way in both directions. This is the line y equals x, that the graph of the inverse function is a reflection of the original graph about this line. So this gets flip-flopped over here, this gets flip-flopped over here, and this one gets flip-flopped over there. So let's summarize what we just learned about the graphs of f and its inverse. If AB is on the graph of f, so that means f of A equals B, then guess what? BA is on the graph of f inverse. That is, f inverse of B equals A.